In this study, the fully actuated dynamic equation of quadrotor as a type of unmanned aerial vehicles, UAVs, is considered in the existence of input delay, model uncertainty, and wind disturbance. Then, a supertwisting terminal sliding mode control approach is planned with the aim of the finite-time attitude and position tracking of quadrotor UAV considering input delay, model uncertainty, and wind disturbance. The finite-time convergence of the tracking trajectory of quadrotor is proved by Lyapunov theory concept. When the upper bound of the modeling uncertainty and wind disturbance is supposed to be unknown, an adaptive supertwisting terminal sliding mode control is proposed. Therefore, the unknown bounds of the model uncertainty and wind disturbance affecting the quadrotor UAV are estimated using the adaptive tuning control laws. Finally, simulation outcomes and experimental verifications are provided to demonstrate the validation and success of planned control technique. In respect to the review of the researches and control methods on quadrotor UAV systems, it can be observed that no attention has been paid to the desired position/attitude tracking of quadrotor system with input delay, model uncertainty, and wind perturbation simultaneously. Moreover, the robust finite-time tacking of quadrotor system in the existence of input delay, model uncertainty, and wind perturbation has not been designed by using the adaptive supertwisting terminal sliding mode control method. In addition, considering the previously published related works, it can be concluded that the compensation inequality for rejection of the input delay of the quadrotor system has not been investigated. Therefore, to obviously clarify the design method, the fundamental contributions of our research on quadrotor UAV systems are listed as consideration of dynamics of the input-delayed quadrotor system under model uncertainties and wind perturbations, recommendation of the supertwisting terminal sliding surface by using the position and attitude tracking error, proposition of the compensation inequality for rejection of the input delay at the aim of the simplification of the control process, demonstration of the finite-time convergence of supertwisting terminal sliding surface using Lyapunov theory, suggestion of adaptive supertwisting terminal sliding mode controller for estimation of the unknown bounds of modeling uncertainty and wind perturbations.